All right, let's take a look at our practice tests. We're told to solve each inequality. And for problem 1, we have the square root of -1 minus 6x is greater than the square root of 3x plus 8. Now, I'm going to tell you in advance for the problems today, I'm going to use a method that is not the fastest, but it will always give you the right answer, no matter how complex the inequality is that you're working with. The idea here is that if you square both sides of an inequality, you'll sometimes get these problems. And just to give you a little insight with a simple example and not to go too far into it, let's just say we had something like -5, and this is less than, let's say, 2. So right now we know that this is a true statement. But what happens if I square both sides of this inequality? This left side would now be 25. Let's keep the less than. If we square 2, we get 4. Well, this is obviously a false statement now. So this is a simple example of some issues that can come up when you square both sides of an inequality. So to avoid this, what I'm going to do is work with the related equation and just test on each side of the solution of that. So what we'll do first is actually find our domain, because that's going to be important. And just a note here, we are working in the real number system unless otherwise instructed on your test. So in the real number system, we know that our radicand has to be non-negative, so greater than or equal to 0. So you have one there and one there. So what you'd have to do is set up a compound inequality with and say that -1 minus 6x is greater than or equal to 0. Then you're going to use your keyword and. You're going to say 3x plus 8 is greater than or equal to 0. Over here, I'm just going to add 1 to both sides of this inequality. Cancel that. You'll have -6x is greater than or equal to +1. Let's divide both sides of the inequality by -6. And remember, if you divide both sides of an inequality by a negative, you have to flip the direction of the inequality symbol. This will cancel and give me x is less than or equal to 1 divided by -6 is -1/6. Over here, I'm going to subtract 8 away from each side of the inequality. We'll cancel this. We'll say 3x is greater than or equal to -8. And then I'll just divide both sides of the inequality by 3. Cancel this. We'll say the keyword and here, and we'll say x is greater than or equal to -8/3. Okay, so coming back up here, if I was showing all the steps to my teacher, I would want to list the domain. Again, if you're just doing this on your own, then you could just use it as scratch work. You could just keep that. You know that x needs to be greater than or equal to -8/3, and it needs to be less than or equal to -1/6. So let's say that the domain is the set of all x such that, again, we're just going to write this as a 3-part inequality. So x is greater than or equal to -8/3, and then less than or equal to -1/6. So if we get a solution and it doesn't fall in this domain, we have to reject it. Okay, so that's very important. And now let's think about solving the related equation. So we have the square root of -1 minus 6x is equal to the square root of 3x plus 8. For this one, since each square root is isolated, I can immediately square both sides. That gives me -1 minus 6x is equal to, you're going to have 3x plus 8. I'm going to solve this resulting equation. So let's add 1 to both sides of the equation here. That would cancel. Let's subtract 3x away from each side of the equation. That would cancel. So -6x minus 3x is -9x. And this equals 8 plus 1 is going to be 9. Okay, from here, I'm going to divide both sides of the equation by -9. Let's cancel this. We'll say x is equal to -1. We know that if we square both sides of an equation, we have to check for extraneous solutions. And so you would plug in a -1 here and also here. So basically, you would have the square root. So -6 times -1 is 6, and then 6 minus 1 would be 5. So this is the square root of 5. This would be equal to, over here, 3 times -1 is -3. Then plus 8 would be 5. So you get the square root of 5 equals the square root of 5. So this is a valid solution. So coming back up here, I'm going to write x is equal to -1. And I'm going to write this in a different way, just so it's more clear what's going on. Let's say we had the square root of -1 minus 6x. I'm going to subtract this guy right here away from each side. So then minus the square root of 3x plus 8. And of course, this would now be greater than 0 in the inequality form, or you could say it's equal to 0 if we're working with the equation. And I'll swap this back in a moment. I just want you to think about what happens if you plug in a -1, right? If we plug in a -1 for x, we know the left side is 0, so you get 0 equals 0. But if you change this back to an inequality, again, all I need to do is test on each side of -1. I know -1 makes this side 0, so I just need to figure out what I need to plug in values that are greater than -1 or less than negative 1. Okay, so you're going to test on each side. The curveball here is it's subject to this domain, so you have to keep that in mind. All right, so you want to come to a number line, or you can make a table, or again, if you're doing this on your own, you can just make some scratch work. It's kind of up to you. But you want to think about negative 1. That's going to be the boundary. So let's go ahead and put that as a little dashed line here. And then again, it's subject to this domain. So if you need this, then you can put it in. If you don't, then again, it's up to you. But negative 8/3, let's just say that's about, and I'll do some different color. Let's say that's about right there. And I'm going to label that as negative. Let me make that a little bit better. So negative 8/3. And then the other guy is negative 1/6. So let's say this is going to be really, really tight here. Let's say that's about right there. Let me do this in different color. So I'll just put this like this. And I'll say that this is negative 1/6 like that. Now, what you'd actually want to do is think about this in terms of the 4 regions. So you have region A, and I'm not including any of these values here. So the negative 8/3, the negative 1, or the negative 1/6, I'm going to think about those separately. So you have region A, you have region B. Let's say this is region C, if I can fit that in there. And this is region D. Okay, so region A would be anything that's less than negative 8/3. We already know that that violates the domain. So negative 8/3 itself is okay. So we'll talk more about that in a moment. But anything less than negative 8/3, that will violate the domain. So that's automatic reject. So I'm going to say that region A, or actually, let me just put A here to make this a little bit shorter. I'll say that A, this is going to be false, or you could put that you're going to reject it. Now, region B, that's going to be between negative 8/3 and negative 1. Okay, so region B, we have to test that. So we don't know at this point. Region C, that's going to be between negative 1 and negative 1/6. So we have to test that, right? We don't know. And then for region D, we're going to reject that because that's anything that's going to be greater than negative 1/6. Again, negative 1/6 itself is okay, right? X could be that, but it can't be greater than negative 1/6. So we have to automatically reject that. That's outside of the domain. So we would say that this is false automatically. So let's test something from region B. And then just for completeness, let's test something from region C as well. So in region B, you could use something like, let's say negative 2. You see that value's in there. I think that would be easy to work with. Let's just come down here. We'll come back up in a moment. So you'd have the square root of negative 1 minus 6 times negative 2, then minus the square root. You have 3 times negative 2, then plus 8. Is this greater than 0? So this right here would be positive 12. And so negative 1 plus 12 would be 11. So this is the square root of 11. And then over here, you have 3 times negative 2, that's negative 6. And negative 6 plus 8 is going to be 2. So this is the square root of 11 minus the square root of 2. Without using a calculator, I think you can see that this is going to be greater than 0, right? The square root of 11 is larger than the square root of 2. And so if you subtract the square root of 11 minus the square root of 2, you will get a positive value, right? So this is obviously greater than 0. So coming back up here, I'm just going to mark that this is true. Right? So anything in region B is going to work. Now for completeness, let's check something in region C. And this is a tight window. So I'm just going to pick something like negative 0.5 or negative 1/2 and just show you that it doesn't work. I'm just going to write here right now that it's false, but I'll just prove that to you. All right, so let's set this up. I'm going to go the square root of negative 1 minus 6 times negative 1/2, then minus the square root of 3 times negative 1/2, then plus 8. And this is greater than 0. Okay, so negative 6 times negative 1/2 is 3. And then negative 1 plus 3 would be positive 2. Over here, 3 times negative 1/2 is negative 3/2. So this is negative 3/2. Now, without going through and getting a common denominator, you can already see that this is a false statement. This is negative 1.5. If I add that to 8, I'm going to get 6.5. So this right here would be larger than this right here. So basically, you're going to have a negative, and that's never going to be greater than 0. All right, coming back up here, we verified that things in region C will not work. So now what I want to do is think about region B and think about the endpoints, whether they will work or not. Okay, so for region B, we have X is greater than negative 8/3, and it's going to be less than this negative 1. So let's think about each of these. Would negative 8/3 work? Yes. Negative 8/3 is in the domain, and it is less than negative 1, right? Things that are less than negative 1 work or satisfy the inequality. So that means that negative 8/3 would work. But again, if you go less than negative 8/3, you're outside of the domain. So you have to exclude those values. But negative 8/3 itself would work. So I'm going to make this less than or equal to here. Then for -1, it's not going to work because this right here we know would be 0. And 0 is not greater than 0. So this is going to be excluded. So when we write our solution, we would basically say that x is greater than or equal to negative 8/3 and less than -1. So we would say a bracket here, so negative 8/3, and then comma, you have your -1, and then use a parenthesis there because it's not included. So that's going to be your interval notation. Let's just put that over there. And then graphically, if you want to put that in, you could put this as negative 8/3. You could put this as -1. And then essentially, you're going to put a bracket here because it's included, or again, some books will use a filled in circle. Then you're going to shade all this up to but excluding -1. So we'll use a parenthesis there, or again, some books would use an open circle. Again, it's really up to you what you do. But this would be graphically, this is your x is greater than or equal to negative 8/3 and less than -1. And then this is your interval notation. All right, let's take a look at problem number 2 now. So here we have the square root of 3x plus 22, then plus 2. This is going to be greater than 4. So the idea here again is I'm going to figure out what is the domain. So take your radicand, which is 3x plus 22, and set it as greater than or equal to 0. So we're going to say 3x plus 22 is greater than or equal to 0. Pretty easy to solve this inequality. What I'll do is subtract 22 away from each side. Let's cancel this away. We'll say 3x is greater than or equal to negative 22. And then from here, I'm going to divide both sides of the inequality by 3. And so we'll cancel this 3 with this 3. You have x is greater than or equal to this negative 22 over 3. So again, I'm just going to write that my domain is the set of all x such that x is going to be greater than or equal to this negative 22 over 3. And then basically from here, I'm just going to replace this inequality symbol with an equality symbol, and then I'm going to solve that resulting equation. So I'm going to say the square root of 3x plus 22, and then plus 2, we'll say that's equal to 4. Okay, so what I want to do in this situation is isolate my radical, so this guy, and to do that I need to subtract 2 away from each side. This would cancel. You'd have the square root of 3x plus 22. Let's make this x a little bit better here. We'll say this is equal to 4 minus 2 is 2. And then we'll square both sides of the equation just so we can get rid of this radical here. And so on the left side, I'll just have my radicand, which is 3x plus 22. This equals, on the right side, 2 squared is going to be 4. And then what I want to do at this point is subtract 22 away from each side of the equation. We'll cancel this away. We'll say 3x is equal to 4 minus 22 is going to be negative 18. And then as a final step, I'll divide both sides of the equation by 3. So now let's cancel this with this and say x is equal to negative 18 divided by 3 is going to be negative 6. So now we have our domain and we have our boundary. So what we'll do, I'm just going to rewrite this as the square root of 3x plus 22. What I'm going to do is subtract 4 away from each side of the inequality. So 2 minus 4 would be negative 2. So then minus 2, and this is greater than 0. For me, this is a little bit easier to work with. And let's come back over here and set up our intervals. So again, x equals negative 6. That was the boundary that we found. So let's find that. So that's going to be negative 6. Put a little dashed line there. Then the other critical value is negative 22 over 3. Now, negative 21 over 3 is negative 7. So this is a little bit to the left of negative 7. So let's just say that it's going to be about right here. And I know that's not exact, but let's just say that's where it is. So this is negative 22 over 3, let's say. And then essentially you have these regions. So let's call this one A, let's call this one B, and let's call this one C. So A would be anything that's less than negative 22 over 3. B would be between negative 22 over 3 and negative 6. And then C would be anything greater than negative 6. And again, those critical values, the negative 22 over 3 and the negative 6, I will consider those separately. In region A, since this violates the domain, it's automatic reject. So we'll just say this is false. Nothing in there is going to work. For region B and for region C, we need a test. Now to test something in B, it looks like negative 7 is available. So let's work with that. So we'll say the square root of 3 times negative 7 plus 22. Let's make this a little bit better here. Then minus 2 is greater than 0. So 3 times negative 7 is negative 21. So this right here is negative 21, then plus 22, which is positive 1. And if we take the square root of 1, we get 1, and 1 minus 2 is negative 1. So this right here is a false statement. So we know that region B, that's not going to work. So we have to reject those values. So coming up here, I'm just going to put false here. Now C is going to work, so I'm just going to put a true for right now, and then I'll prove that to you. So for C, I would just pick 0. It's nice and easy to work with. So let's say we'd have the square root of 3 times 0, which is 0. So the square root of basically 22, then minus 2 is greater than 0. Now for the square root of 22, it's about 4.7. So you can see that this is larger than this 2 that's being subtracted away. So this is going to be a positive value, so it will be greater than 0. So anything in region C will work, right? So that will be true. Now coming back up here, since we know that things in region C would work, we would start with our solution by saying that x is greater than negative 6. Now would negative 6 itself work? Well, think about it. Negative 6, if I plug that in here, is going to give me 0 on the left-hand side, right? So you'd have 0 is greater than 0, which is a false statement. So negative 6 would not work. So this would be your solution. And if you wanted to do interval notation, you could just say you put a parenthesis next to negative 6. This is going to go out to positive infinity. And then graphically, we would find negative 6. And again, you could put a parenthesis there, or you can do the open circle if you like that. And then we're going to go and shade everything out to positive infinity. So let's make sure we shade in this arrow. All right, let's take a look at problem number 3 now. So we have the square root of 10 minus x, and this is less than or equal to. We have the square root of 3x plus 7, and then minus 3. So the first thing I'm going to do is find my domain. So I'm just going to take this radicand here, which is 10 minus x, and I'll say that that is greater than or equal to 0. Then I'm going to use my keyword and. I'm going to take this radicand here, which is 3x plus 7. So 3x plus 7. And again, it has to be greater than or equal to 0. So let's solve this compound inequality real quick. So on the left, what we can do is actually just add x to both sides of the inequality. I think that's the fastest way. So we'll say 10 is greater than or equal to x, or you could flip that around and say that x is less than or equal to 10. And then for the other guy, let me just write and in here. We will subtract 7 away from each side, cancel this. You'll have that 3x is greater than or equal to negative 7. Let me make this a little bit more clean. And then we will divide both sides of the inequality by 3. Cancel this. So we'll say x is greater than or equal to negative 7/3. Okay, let's consider this real quick. And so for the domain, let me write this out. So for our domain, we will say that it's the set of all x such that x has to be greater than or equal to this negative 7/3, and it has to be less than or equal to positive 10. Okay, so now let's solve this related equation. So we'll say that we have the square root of 10 minus x. We'll say this is equal to the square root of 3x plus 7, and then we have minus 3. Okay, so I have this radical on the left isolated, so you can immediately square both sides, but unfortunately that's not going to clear all the square roots involved. So this one squared, we know we just get the radicand, so this is 10 minus x on the left side. Then this equals on the right side, again, you have to use your formula. So square this guy, you get 3x plus 7. Then you have a minus, so you bring that, and then it's 2 times this guy times this guy. So 2 times 3 is 6, then times your square root of 3x plus 7. Let me actually slide this down here. Then plus your 3 being squared would be 9. Okay, we need to isolate this radical. So this guy right here. And so to do that, I'm first going to consider that 7 plus 9 is 16. So let's just erase this from here and here. And actually, I'll just put it at the end. I'll subtract it away from each side of the equation like this. And so this is going to cancel. And then additionally, I can also subtract 3x away from each side of the equation. Let's make this a little bit cleaner here. We'll cancel this. And so my left-hand side now will be 10 minus 16, which is negative 6. So we have negative 6. And then negative x minus 3x is negative 4x. And this equals, you have negative 6 times the square root of 3x plus 7. So just like I talked about when we were discussing how to solve radical equations, you could divide everything here by negative 6, but then you'd have fractions over here. So it's really personal preference. What I would do to make things easier, I would first reorder this and say this is negative 4x minus 6. Let me move this out of here and basically drag this up. So what I would do is actually just divide everything by negative 2 and see where that gets me. So basically, negative 4 divided by negative 2 is going to be 2. So this would be 2x. Negative over negative is positive. 6 divided by 2 is 3. And this equals negative over negative is positive. 6 divided by 2 is 3. So this is 3 times the square root of 3x plus 7. Now you still have a number here, but at least you don't have to work with some nasty fractions. So I think this is preferable, at least for me. So what I'm going to do now is just square both sides. And let's see where that gets us. So for this guy, the first guy squared is 4x squared. Then plus 2 times this guy times this guy. So 2 times 2 is 4, times 3 is 12. Then times x, then plus 3 squared is 9. This equals, when you square this guy, you have to be really careful. It's 3 squared, which is 9, multiplied by this guy being squared. So you have to wrap this in parentheses. You would get 3x plus 7 inside. And then you just need to use your distributive property here. So let's write 4x squared plus 12x plus 9 is equal to 27x plus 63. And all I did here was multiply 9 times 3x to get 27x. Then plus, you have 9 times 7, that's 63. So that's all I did. So now we have a quadratic that we need to solve. And for this, I would put it in standard form. See if it's something you can factor. If you can't, then just use the quadratic formula. So I would subtract 27x away from each side. Let's cancel that. Let's subtract 63 away from each side. Let's cancel that and put this as 0. So on the left, you'll have 4x squared. And then 12x minus 27x, that's going to be negative 15x. And then 9 minus 63, that's going to be negative 54. So minus 54, and this equals 0. So this is something you can factor, but it's actually not that easy to factor. So you could use the quadratic formula if you have to. Again, it's really up to you. I'm just going to factor it real quick because I already know how it works out. So I'm going to put a 4x here and an x here. Now remember, with 4, it's either 4 times 1 or 2 times 2. So if this didn't work, you'd have to check 2 times 2, okay? Now with 54, you've got 1 and 54, which that's probably not going to work. You couldn't put the 54 here because you'd have a common factor of 2, but you could put the 54 here and the 1 here. But 4 times 54, that's 216, and you're subtracting away 1 because this is a minus here. Again, everything is in terms of absolute value. So that's not going to get you to negative 15 or positive 15 again in terms of absolute value. Thinking about the next one, it's 2 and 27. You can't put the 2 here, but you could put it here, and you could put the 27 here. Now, 4 times 2 is 8, and then you've got 27. 27 minus 8, that's 19, and you're trying to get to 15, so that's out. Now, 54 is also divisible by 3, so you've got 3 and 18, so you can't put the 18 here, but you could put the 3 here and the 18 here. 4 times 18 is 72, and then 72 minus 3 would be 69, so that's not what we need. And then what else can we do? So it's not divisible by 4 or 5, but you could do 6 times 9. Now, you cannot put the 6 here because you'd have a common factor of 2, but you could put the 9 here and the 6 here. Now, it turns out this is what you're going to need. 4 times 6 is 24, and 9 times 1 is 9. 24 minus 9 is 15, but you have to make the signs work. So this needs to be negative, and this needs to be positive. So that will give me a negative 24x, and this would give me a plus 9x. So negative 24x plus 9x is negative 15x, so this is what we want. Okay, so let's say that 4x plus 9 is equal to 0. Or let's say that x minus 6 is equal to 0. And what I'll do here is subtract 9 away from each side. We'll cancel this away and say 4x is equal to negative 9. Let's divide both sides of the equation by 4. And let's cancel this and say that x is equal to negative 9 fourths. Then over here, let's add 6 to both sides of the equation. We'll cancel this. So also we get x equaling 6. Now again, these are proposed solutions. We did square both sides of an equation, so we need to check for extraneous solutions. All right, so let's check each one of these. So I'm going to tell you in advance, negative 9 fourths is not going to work. Instead of going through and trying to get common denominators, you can just use this as a decimal. So negative 9 divided by 4, that's going to be negative 2.25. So you'd have the square root of 10 minus a negative 2.25. So that's like plus 2.25. So this would be 12.25. And we're saying this is equal to, we have the square root of 3 times negative 2.25. That's going to be negative 6.75. And you're adding that to 7. That's going to give me 0.25, or you can think about that as a fourth. Now the square root of a fourth is going to be a half. So basically this is 0.5, or you could say it's a half, then minus 3. We don't really need to go any further here, because we can see that this side's going to be positive and this side's going to be negative. So we know that this is going to be rejected, so this does not work. Okay, the other one's really easy to check. So you have 10 minus 6, that's 4. The square root of 4 would be 2. Over here, 3 times 6 is 18. 18 plus 7 is 25. The square root of 25 is 5. And then 5 minus 3 would be 2 as well. So this one works as a solution. So 6 is what we want. So coming back up here, I'm just going to say x is equal to 6. We have all the information we need. I'm going to keep this inequality in this form here, bringing everything over to one side, in this case, doesn't make it any faster for me. Maybe it does for you. It's really personal preference. All right, let's come to the number line now and set up our little intervals. So I'm going to start with 6. So that's going to be my boundary here. So I'll make a little vertical line. And then also I'm going to think about -7/3. So if you don't know what that is, again, if you don't have a calculator handy, then -6/3 is -2. So this is basically -2 1/3. So let's just say it's going to be about right here approximately. Doesn't have to be perfect. We'll say this is -7/3, or you can put -2 1/3, whatever you want to do. Then for 10, let's put that about right there. Let's make a little vertical line there as well. I'm just going to set up my little regions. So let's say that this guy is A. So that's anything that's less than -7/3. Let's say that this is B. So that's between -7/3 and 6. Let's say this is C. So that's between 6 and 10. And let's say this is D. So that's greater than 10. So we know for A and D, they're automatic rejects, right? So they violate the domain. So if I set this up and say A is going to be false, and then I'll have B, I've got to check that. C, I've got to check that. And D, we know this is going to be false. Let me try to slide this up here. And I drug my minus sign, so let me put that back in there. So we want to start in region B. So I would pick 0, see what that does. So you would basically have the square root of 10 minus 0 is 10. So this is the square root of 10 is less than or equal to. Here, if you plug in a 0, you'd have the square root of basically 7 and then -3. So this is something I would use a calculator for. I'm just going to tell you in advance it doesn't work. The square root of 10, let's just say that's about 3.16. So this is an approximation. I'll just say it's about 3.16. We're saying is this less than or equal to? Punch in the square root of 7 minus 3 in your calculator. You're going to get a negative value. It's going to be negative 0. Let's just say it's 35. We'll just stop there. You can tell because this is positive and this is negative, this is a false statement, right? This guy right here is not going to be less than this guy right here because this is, again, a positive and this is a negative. A positive cannot be less than a negative and it can't be equal to a negative, so this is false. So coming back up, I'll just write that this one is false, and then C is going to be true. I'll write that in now, and then I'll prove it to you. Let me make that a little bit cleaner there so that it's legible. So for C, we could pick something like 7 or 8 or whatever you want to do. Let's just pick 7. So we would have the square root of 10 minus 7. That's going to be 3. So the square root of 3 is less than or equal to, you're going to have the square root of 3 times 7 is 21. 21 plus 7 is going to be 28. So you've got the square root of 28. Now, 28 is 4 times 7. So you could say this is 2 times the square root of 7 if you wanted to. We're probably going to use a calculator, but just for completeness, we'll put that in there. So then I have -3. So punch in the square root of 3 on your calculator. You're going to get about 1.73. So 1.73. We'll say this is less than or equal to 2 times square root of 7 minus 3. You're going to get about 2.29, let's say. So 2.29. And again, these are approximations, but it's close enough to where we can see that this side is less than this side. So it's going to be a true statement. So now that we know that numbers in region C are going to work, we can set up our solution. Let's just start with region C. We'll say x is greater than 6 and less than 10. Now we want to consider 6 and 10. Let's first think about 6. We have over here this x equals 6. Remember, this was the solution for our related equation. Well, here we have this non-strict inequality. So if I plug in a 6 for x, I'm going to get the same value on the left as I get on the right. So that means 6 would be included in the solution for this inequality. So let's go ahead and make this into a less than or equal to. Now, let's think about 10. Remember, on this side of 6, we're going to be in the solution region, so anything greater than 6. What stops us is that anything greater than 10 is not going to work because it violates the domain. But 10 itself does not violate the domain, so it will be in the solution set. So I'm going to go ahead and say this is a less than or equal to also. So here x would be greater than or equal to 6 and less than or equal to 10. All right, so let's put this in interval notation. So I'll just say we'll have a bracket there and then a 6, a comma, we'll put a 10, and then a bracket. Now graphically, let me start by putting a little notch here for 10. And then I'm going to use a bracket here at 6. And I'm going to use a bracket here at 10. Again, if you want to use a filled in circle, that's up to you. And then I'll just shade everything in between there. So basically we're saying that x can be any number that is 6 and then going up to and including 10. All right, let's take a look at problem number 4 now. So we have the square root of 8 minus x. This is greater than or equal to the square root of 2x minus 7. Then we have minus 3. All right, let's start with the domain. So I'm going to take this radicand here, which is 8 minus x, and we'll say that this is greater than or equal to 0. Then I'm going to say and. I'm going to take my other radicand, which is 2x minus 7. And again, we'll just say that that guy needs to be greater than or equal to 0 as well. Okay, so solving this one is pretty simple. I would just add x to both sides of the inequality. You would get 8 is greater than or equal to x, or you could flip that around and say that x is less than or equal to 8. Okay, for this one over here, what I would do is add 7 to both sides of the inequality. Let's cancel that away. We'll say that we have 2x is greater than or equal to 7. Let's divide both sides of the inequality by 2. We'll cancel that. And so I'll write my keyword and here, and I'll say x is greater than or equal to 7 halves, or in decimal form, you could put 3.5. So let's write our domain. So we'll say that the domain here is going to be the set of all x such that we're going to have x is going to be greater than or equal to our 7 halves, and it'll be less than or equal to 8. Okay, so let's solve the related equation. We'll say the square root of 8 minus x now is equal to, we'll say the square root of 2x minus 7, and then we'll have minus 3. Okay, so I'm going to square both sides so I can get rid of the square root on the left. Unfortunately, I'll still have a square root on the right, but we'll deal with that in a moment. So I'll just have the radicand here. This is 8 minus x, and this is equal to. Here I'm going to square this guy, so that would be 2x minus 7. Then you have the minus. You have 2 times this guy times this guy. 2 times 3 is 6. And then times your square root of 2x minus 7. And then squaring the last guy, if I square 3, I get 9. So this is plus 9. Okay, so I can clean this up just a little bit. Again, I'm trying to isolate this guy right here. So I can say that negative 7 plus 9 is positive 2. Let me just erase that from here and just put this as a 2. And then what I'm going to do is subtract 2x away from each side. And then I'm going to also subtract 2 away from each side. And let's cancel this, and let's cancel this. So let's say that we have 8 minus 2, that's 6. And then basically negative x minus 2x would be negative 3x. And this equals negative 6 times the square root of 2x minus 7. Now, like we've talked about before, you could divide everything by negative 6 to make this side simpler, but you're going to end up with a fraction over here, and you probably don't want to work with that. So I'm going to just divide everything by negative 3. I think that's just going to make things a little bit easier for us. So 6 divided by negative 3 is negative 2. Then negative 3 divided by negative 3 is 1. So this would just be plus x. And this would be equal to negative 6 over negative 3 is 2. And then this is times the square root of 2x minus 7. Now over here, I would just flip this around and say it's x minus 2. And then I would just square both sides. So square this side and then square this side. Over here, just use your formula. So this is x squared minus 2 times x times 2. So this is minus 4x. Then plus 2 squared is 4. And this equals square 2, that's 4. Then you're going to wrap this in parentheses. When you square this, remember you get 2x minus 7, but you need to multiply 4 by each term there. So 4 times the quantity 2x minus 7 is what you're going to get there. And if you go through and distribute, you would have 8x and then minus 28. So let me erase this and just drag this up here. All right, so a pretty simple quadratic equation to solve. I'm just going to add 28 to both sides and then cancel this away. Subtract 8x away from each side. Cancel this away. Let's put this as 0. We'll have x squared, and then negative 4x minus 8x is negative 12x. 4 plus 28 is 32, so plus 32, and this equals 0. Very easy to factor this and solve it that way. So let's do that. So we'll put an x here and an x here. Two integers that sum to negative 12 and have a product of positive 32. That's going to be negative 8 and negative 4. So here we would just say x minus 8 is equal to 0, or x minus 4 is equal to 0. Let's add 8 to both sides of the equation. Let's cancel this away and say x is equal to 8. Let's add 4 to both sides of the equation. Cancel this away. We'll say x could also be 4. But again, these are proposed solutions, so we have to check them. All right, so coming back, I'm just going to tell you in advance that 8 works and 4 doesn't. If you plug in an 8 for x, you get 8 minus 8, which is 0. Square root of 0 is 0. And this equals 2 times 8 is 16. 16 minus 7 is 9. Square root of 9 is 3. 3 minus 3 is 0. So this one works. 4 does not work. So here you have 8 minus 4, which is 4. Square root of 4 is 2. And this should be equal to 2 times 4 is 8. 8 minus 7 is 1. The square root of 1 is 1. And then 1 minus 3 is negative 2. So this solution here of x equals 4 is extraneous. So we're going to reject that one. So we just want this x equals 8. So coming back up here, I just want to put x equals 8. Now you have an 8 here and an 8 here. So that's going to make things a little bit simpler. Let me copy this real quick. So we have the square root of 8 minus x is greater than or equal to. we have the square root of 2x minus 7 and then minus 3. Once again, I'm not going to write everything on one side. When it gets complex like this, I don't think it helps that much. You just pretty much have to use a calculator. All right, so coming to the number line, let's think about 7 halves, which in decimal form is 3.5. So let's just say that's about right here. It's not perfect, but that's close enough. And then we have 8, so let's put that there. And that's basically it. So we're going to have 3 intervals here. Let's call this A, let's call this B, let's call this C. Now for A and C, those are automatically going to be rejected because they violate the domain, right? A is going to be anything that's less than 7 halves. So this is going to be false. Then for B, we have to check it. That's between 7 halves and 8. Then for C, we're going to reject because that's anything greater than 8. Again, that violates the domain. So this is automatically going to be false. So really, we just want to check something in B. You could just grab something like, let's say 4. I think that'd be pretty easy to work with. Now, you might remember from the equation when we plugged in 4, we got 2 on one side and we got negative 2 on the other side. But let's just go through it again. So if I plug in a 4 there and I plug in a 4 there, we're going to get 8 minus 4, which is 4. Square root of 4 is 2. So that's the left-hand side. This is greater than or equal to 2 times 4 is 8. 8 minus 7 is 1. Square root of 1 is 1. So this is 1 minus 3, which is negative 2. So this is a positive and this is a negative, and a positive is always greater than a negative. So this is definitely true, right? 2 is greater than negative 2. We can say that this is true for region B. So getting our solution is pretty easy. We just grab region B. So we'll say that x is greater than 7 halves and less than 8. And we're going to think about 7 halves and we're going to think about 8. Now, first and foremost, does 7 halves work? Well, yeah, if I'm less than 8, I'm going to work. But again, anything less than 7 halves, that violates the domain, but 7 halves does not. So this is going to be included. So x here would be greater than or equal to 7 halves. So we want this right here to be less than or equal to. Now, does 8 work? Well, again, this is a non-strict inequality. So if I plugged in an 8, the left and the right sides would be equal. So this would work as well. So I want this to be a less than or equal to also. So here, x would be greater than or equal to 7 halves and less than or equal to 8. So coming back here, I'll just write this in interval notation. So we'll put a bracket, 7 halves, comma, 8, and then a bracket. And then let me put my notch in here for 7 halves again. So let's just say it's about right there. That's going to be 7 halves for us. And I'm just going to use a bracket there. Or again, you can use a filled in circle. And then I'm going to use a bracket at 8 and then just shade everything in between. So from 7 halves, x can be that, going up to and including 8. All right, let's take a look at problem number 5 now. So we have 1 plus the square root of 6x minus 2 is less than or equal to. We have the square root of 9x minus 2. And what I'm going to do is first find my domain. So I'm going to take this 6x minus 2, this radicand here, and I'll say that that needs to be greater than or equal to 0. Then I'll use my keyword and. I'll work with my other radicand, which is going to be this 9x minus 2. And again, this has to be greater than or equal to 0 as well. Okay, on the left, let's add 2 to both sides of this inequality. We'll cancel this and say 6x is greater than or equal to 2. From here, let's divide both sides of the inequality by 6. We'll cancel this away and say x is greater than or equal to. 2 over 6 is basically going to be 1/3. And then let me write my keyword and here. And over here, I'm just going to add 2 to both sides of the inequality. We'll cancel this. We'll have 9x is greater than or equal to 2. From here, we'll divide both sides of the inequality by 9. We'll cancel this. So we'll have x is greater than or equal to 2/9. Now, this one is a little bit tricky when you see it, if you're not used to working with compound inequalities. Basically, since you have a greater than or equal to and then another greater than or equal to, you're going to take the more restrictive one. So how do we figure out which one's more restrictive? Well, think about 1/3 as a decimal. Just punch that into your calculator. You're going to get 0.3, where the 3 repeats forever, right? You get 0.333. That 3 is going to continue forever and ever and ever. Then for 2/9, punch that into your calculator. You get 0.2, where the 2 continues forever. So 0.2, 2, 2, 2, so on and so forth. Now, thinking about this, again, which one's more restrictive? Well, this one will be, right? Because this one is larger, so it's to the right of the other one. You can even look at this on a number line if you're confused by this, and just think about which one's more restrictive or which one includes fewer numbers. So let's say that this is, let's say 1. Okay, wherever you want to put it, it's fine. And let's say that this is 0 here. Well, if we have something like 1/3, let's just say that that's going to be somewhere about, let's say right there. So let's say this is 1/3. And then what's going to happen is 2/9 is going to be to the left of that. So let's just say it's right here. Again, it doesn't matter if it's exact. Let's just say this is 2/9. You're just going to see that 2/9 is to the left of 1/3. And so if we were considering this guy right here, right, that would include more numbers. So this would include these numbers right here, right, which would not be included in the other one. So that's important to understand. So we want to go with the more restrictive one because we have and, because it has to work in both. So we want x is greater than or equal to 1/3. So let's come back up here and write our domain and say that it's going to be the set of all x such that x is greater than or equal to 1/3. Okay, so now let's solve the related equation. So 1 plus the square root of 6x minus 2. This is equal to the square root of 9x minus 2. And what I'll do here is just immediately square both sides so I can get rid of this radical on the right. Unfortunately, I'll still have a square root on the left. So on the left, it's our formula. So 1 squared is 1 plus 2 times 1 times this. So 2 times square root of 6x minus 2. Then plus this last guy squared, which is 6x minus 2. This equals, if I square this guy, I get the radicand, which is 9x minus 2. So again, I need to isolate this guy right here. Pretty easy to do at this point, I think. So you see that you have -2 here and -2 here. You could just get rid of it from each side. I think that's probably the easiest thing to do. And then you could just subtract 1 away from each side. Let's cancel that from there. And then let me subtract 6x away from each side. Cancel that from there. So you have 2 times the square root of 6x minus 2. This equals 9x minus 6x is 3x, and then basically minus 1. Now, at this point, you could divide both sides of the equation by 2 so that this is a little bit easier to work with, but you're going to make this one more complicated, so it's really a trade-off. Okay, which one do you want to struggle with? I'm just going to leave it as is, and I'm going to square both sides. And essentially, I'm going to say that this is 4 times the quantity 6x minus 2. So again, I can't stress this enough. Make sure when you do something like this that you use parentheses here. The 4 needs to multiply by the 6x and the -2. Then this equals, I'm going to square 3x, that's 9x squared. And then minus 2 times 3x times 1 is going to be 6x. And then plus 1 squared is 1. Okay, just using my distributive property, 4 times 6x is 24x. Then minus 4 times 2 is 8. This equals 9x squared minus 6x plus 1. What I'll do from here is subtract 24x away from each side of the equation. We'll cancel this. I'm going to add 8 to both sides of the equation. We'll cancel this. Let's say this is 0 over here. I'm just going to flip this around and say it's 9x squared. Then basically negative 6x minus 24x is negative 30x. Then we'll have 1 plus 8, which is 9, and this equals 0. Okay, so definitely something I'm going to solve using factoring. You can divide everything here by 3. If you want to make it a little bit easier to work with. So this is 3x squared, then minus 10x, then plus 3 is equal to 0. And so really easy to factor this. This is 3x, and this is x. And then basically 3 is only 1 times 3, or negative 1 times negative 3. Now this is a negative and this is a positive, so this is basically going to be a negative and a negative. Now the 3 can't go here because you'd have a common factor of 3, so it has to be a -1 here and a -3 here. That's really the only possible choice given all these conditions. Well, this would be negative 9x, and this would be negative x. Negative 9x minus x would be negative 10x, so we are good to go. Let's go 3x minus 1 is equal to 0. Or let's go x minus 3 is equal to 0, and then I'll add 1 to both sides of the equation, cancel this. We'll get 3x is equal to 1, divide both sides by 3. Let's cancel this away and say x is equal to 1/3. Then over here, let's add 3 to both sides, cancel this. So x could also be 3. So again, these are proposed solutions. I'll just tell you in advance that they're both going to work. I can plug in a 1/3 for x and see if that works, and a 3 for x and see if that works. So we have 1 plus the square root of 6 times 1/3 would be 2. 2 minus 2 is 0. So this is the square root of 0, which is 0. So this is just 1. That should be equal to the square root of 9 times 1/3 is 3. 3 minus 2 is 1. Square root of 1 is 1. So again, you're going to get 1 equals 1 here. So this one works. Now in terms of 3, I think we could just eyeball this one. So 6 times 3 is 18. 18 minus 2 is going to be 16. The square root of 16 is 4. So you have 1 plus 4, which is 5. That equals. Over here, 9 times 3 is 27. 27 minus 2 is 25. The square root of 25 is 5. So this one works as well. So both of these are going to work. So let's come back up here. And I'm just going to copy this in its current form. So 1 plus the square root of 6x minus 2. We'll say is less than or equal to. We'll say the square root of 9x minus 2. Okay, so coming back up here, really we just need to think about 1/3 and 3. That's the only critical values we're going to have. Remember, 1/3 and 3, those are solutions. But then also with 1/3, if anything is less than 1/3, it can be 1/3 or greater. But if it's less than that, we're going to reject it. So let's find 1/3. Let's just say it's about right here. I think that's probably close enough. Let's say that's 1/3. And then for 3, that's right here. And basically we can set up our regions, or you can say intervals, or whatever you want to say. So this is A, this is B, and this is C. So A is going to be anything that's less than 1/3. So we already know that that violates the domain because X has to be equal to 1/3 or greater. So this is an automatic reject. We'll say this is false. Now B and C are open. We don't know. So for B, we have to test that's between 1/3 and 3. And then for C, we have to test that's greater than 3. So let's check that real quick. So let's think about something like maybe 2, or you could use 1, whatever you want to do. Let's just use 1. I think that might be easier. Let's see if this works. So 1 plus the square root of, you'd have 6 times 1, which is 6, and then minus 2, which would be 4. So the square root of 4 would be 2. So this over here would be 1 plus 2 or 3. So let's put this as 3. This is less than or equal to 9 times 1 is 9. Then minus 2 is 7. So this would be the square root of 7. Now this is something you could just punch into your calculator. The square root of 7 is about 2.65. So this is going to be false. Okay, this is not going to work. Let's come up here and say this is going to be false. And I'll just say this is going to be true. And I'll prove that to you. Let's pick something like, let's just say 4. That won't be that bad. So let's say 1 plus the square root of 6 times 4 is 24. 24 minus 2 is 22. This should be less than or equal to the square root of 9 times 4 would be 36. And then 36 minus 2 would be 34. So again, this is just something you can punch into your calculator. 1 plus the square root of 22. Let's just say that's about 5.69. Again, it's an approximation. Is this less than or equal to the square root of 34? That's about 5.83. So this is a true statement. So let's think about our solution now. So we're going to start with region C. So for that, it's anything that's greater than 3. So X is greater than 3. Now, is 3 itself included? Remember, 3 is a valid solution to the related equation. So if I plug it in, I get the same value on the left as I get on the right. Now keep in mind here, this is a non-strict inequality. So 3 will work. So we're going to say X is greater than or equal to 3. But there's another thing you have to do here. Remember, we said that 1/3 would work as a solution as well. And this is a non-strict inequality, so we have to make sure that we include it. So these are the types of things that you can miss pretty easily if you're not thinking about checking all these things. So I would put that X is greater than or equal to 3. Then you would just put or X could also be equal to 1/3 because that would satisfy this guy as well. If I plug in a 1/3 for X, I would get the same value on the left as I get on the right. So this guy would be satisfied. Now this is going to be strange in interval notation, but in case you do want to write it that way, what I would do is actually reorder this and say that X is equal to 1/3. And then I'll put or X is greater than or equal to 3. So let me erase this and put this like this. And then in interval notation, what I'll do is basically put a bracket here. It's the same number. So how do you write that as an interval? You just put 1/3 here next to this bracket, a comma, and then 1/3 here next to this bracket. And I know this looks really, really weird, but that's just how you do it. You're basically saying that it's just 1/3 as the number. Then you'll put the union symbol. And then here it's anything that's greater than or equal to 3. So let's put a bracket, a 3, and this goes out to positive infinity. All right, so graphing this, again, let's put a little notch here at 1/3. Let's just say that's right there. So this is 1/3. Now, generally, I use a bracket, but for this one, I would actually use a filled-in circle. So I'm just going to fill that in right there like that. This should show that 1/3 is a solution. And then at 3, I'm going to put a bracket there. And then I'm just going to shade everything to the right. So again, if you want to make this more consistent, you could erase this and put a filled-in circle there just so it looks more clean.